The objective was to build a steamboat and to determine the thermal efficiency of it.
In order to calculate the buoyant force, we use the submerged volume and the gravity and density, and then in order to calculate the thermal efficiency, we use the equation. The equation we used in order to calculate the buoyant force was density of the water, gravity, and the submerged volume equals to the mass times the gravity.
To obtain the thermal efficiency formula is needed. The formula consists of work over heat.
For this experiment, we used several materials. We used MDF wood, solid alcohol, silicone, the silicone gun, aluminum foil, tin can, and straws. Also, we used SolidWorks in order to design the parts and later laser cut them in the laser cutting machine.
First step to make our boat was to design it on a paper. So we first take the measures with a rule, we design it, and then we went to SolidWorks. So in SolidWorks we make every single piece with it, and then we went to the laser so we can cut it in the MDF.
After that, we glue all the pieces together in order to make the boat, and then we cover all by aluminum in order to not to catch up in fire. Then we made the boiler using a can and straws so that the motor will work. And after that, we use solid alcohol in order to boil and to have fire.
The buoyant force, which is density of the water times gravity times volume submerged, that equals the mass of the boat times gravity. Mass is 0.311 kilograms. Our density is the density of the water, that is 1,000 kilograms between meters cubed. Our volume submerged, we did the volume submerged equals to the mass of the boat between the density of the water. This yields to 3.11 times 10 to the minus 4 meters cubed.
We had to calculate the heat emitted, which is the difference of the heat at the temperature of 19 and the heat at the temperature of 92, which is the boiling point of water. After that, we had to calculate the heat produced by the phase change, which is calculated with the mass by the latent heat of vaporization. The sum of the heat emitted and the phase change heat led to 642 kilojoules.
Calculating the thermal efficiency, we need to calculate the work, which is power times the change in volume. After this, we calculated the efficiency, which is work between the total heat. This yields to a number of 2.7 times 10 to the minus 4.
We can say that the boat will float due to the numbers that we had already calculated with the buoyant force, and also we can conclude that thermal energy is very, very inefficient. We can see that in the experiment the thermal efficiency was very, very little, and thus most of the energy you have to input in the system will be lost in order to make the phase change, in order to make the internal energy change. So it will be very, very little energy that is actually making the boat move. The most part of the energy will be lost trying to make the phase change and the internal energy to make the boat move. So we can say that thermal energy is very inefficient, and even though we can make some things to try to make this more perfect and to try to make this more efficient with maybe better materials, maybe metallic straws, maybe a better cauldron. Even if we change those things, the efficiency will not change because it takes a lot of energy in the change in internal energy than actually the useful work that makes the boat move.
Thank you, Sammy.
Thank you. Bye.
Bye.